We sterilize surgical instruments by holding them at 121 degrees Celsius. For most of a century, that number was the definition of clean. Of dead. Nothing, we were certain, could live through it. Then scientists grew a microbe at exactly that temperature, and instead of dying, it doubled its numbers. That is the recurring nightmare of this field. Every place we ever declared off-limits to life, we eventually went and looked. Inside acid that dissolves metal, 2 miles down in solid rock, in water cold and dark and crushing enough to kill almost anything. And nearly every time, something was already there, living. Sometimes looking back. Over the next 10 minutes, I'll walk you up a ladder from merely hostile to genuinely impossible. And I'll show you 3 things. A bacterium you can hit with enough radiation to shatter its DNA into hundreds of pieces, and it stitches itself back together in hours. An ecosystem 2 miles underground made of a single species that has never touched sunlight and runs on nothing but radioactivity. And one animal that survives all of it, including the open vacuum of space. Hold those 3. We pay every one of them off. Welcome to the lab. 7 environments where life has no business existing, ranked not by how strange the organism looks, but by how impossible the place is. We start somewhere merely lethal. We end somewhere that should be sterile rock and empty vacuum. Subscribe before we open the first sample. The lab opens a new specimen every week, and that button is what keeps the lab doors open. Specimen 1. Heat. Picture a deep-sea hydrothermal vent, a crack in the seafloor where water superheated by magma erupts at temperatures past 300 degrees. On the walls of these chimneys lives the Pompeii worm. Its tail sits in water measured as hot as 80 degrees, while its head stays in much cooler water near 20, the steepest temperature gradient any animal on Earth is known to endure. But the real record holder here is invisible, an archaeon called Strain 121, the same one from the cold open, whose name is its whole resume. It reproduces at 121 degrees, the exact temperature we trust to sterilize a hospital. Heat that unspools the proteins of nearly everything alive is, to this thing, simply where it lives. Heat tears molecules apart. The next environment does the opposite. It crushes. Specimen 2. Pressure. Drop to the bottom of the Mariana Trench, almost 11 kilometers down, farther below the sea than Everest stands above it. The water overhead bears down at around 8 tons per square inch, roughly 1,000 times the pressure at the surface, enough to implode a steel submarine. And yet, gliding through that darkness near 8,000 meters, there is a fish. The Mariana snailfish. Not a fanged horror, but a small, pale, almost translucent thing with soft, flexible bones, and no scales, because rigid armor would simply be crushed. Below it swarm scavengers called amphipods, some building shells out of aluminum. Where the pressure should flatten everything, life just got softer and stayed. Pressure and heat are physical. The next threat is chemical, and it eats you from the outside in. Specimen 3. Acid. In volcanic fields, hot springs leak sulfuric acid into the ground until the water reaches a pH near 0, close to the strength of the acid in a car battery, corrosive enough to dissolve metal. Drop almost any living cell in, and its membranes fail in seconds. But an archaeon called Picrophilus lives there, growing best at a pH of about 0.7. And here is the part that makes it genuinely alien. It does not just tolerate the acid, it needs it. Raise the water toward neutral, toward the gentle chemistry your own cells require, and Picrophilus falls apart and dies. Our safe is its poison. Acid is a fast death. The next place kills slowly, inside what looks impossibly like a lake at the bottom of the sea. Specimen 4. Salt. On the floor of the Gulf of Mexico, there are lakes, real ones, with a shoreline, a surface, and waves that ripple when something disturbs them. They exist because the water inside is so loaded with salt that it is far denser than the ocean above and refuses to mix, pooling into a separate body you could watch a submarine float on. It holds almost no oxygen, and it is salty enough that nearly any animal which swims in is killed within seconds. then preserved on the bottom because even rot cannot take hold. And still, right at the shoreline, life crowds in. Beds of mussels ring the edge, fed by bacteria in their gills that build food from the chemicals seeping up. A dead lake with a living coast. Quick pause, because we are halfway up the ladder and it is worth stopping on a thought. If life takes hold in boiling water, crushing dark, battery acid, and a poison lake, then the list of places it could survive somewhere else just got a lot longer. So, my question, do you think we already have neighbors out there, somewhere in this solar system? Drop a yes or a no in the comments, and I'll tell you where I would send the next probe at the end. Everything so far has been a place. The next one is a weapon. We did not find this organism somewhere extreme. We found it by trying to kill it, and failing. Specimen 5. Radiation. In 1956, scientists were sterilizing canned meat with a blast of gamma radiation strong enough to kill anything known to science. The meat spoiled anyway. The culprit was a bacterium we now call Deinococcus radiodurans, nicknamed Conan the Bacterium, one of the most radiation-resistant organisms ever found. About 5 grays of radiation will kill a person. Deinococcus shrugs off thousands of times that. The radiation does what it always does. It shatters the cell's DNA into hundreds of broken pieces. For anything else, that is the end. But Deinococcus keeps spare copies of its genome and a repair system so precise that within hours it gathers the fragments and stitches the whole thing back together, error-free. There is even a black fungus growing inside the Chernobyl reactor, in radiation that kills a human in minutes, that may be feeding on it. This was Promise 1. A creature that shrugs off radiation that would erase almost anything else. Deinococcus survives radiation as an attack. The next organism survives on radiation as a meal in a place with no sun at all. Specimen 6. The Deep. Almost 2 miles beneath a South African gold mine sealed in cracks and solid rock, in total darkness and 60-degree heat, there is life. And when scientists sequenced it, they found something never seen before. An entire ecosystem made of a single species. Everywhere else on Earth, life is a web of things eating other things. Down here, one bacterium, Desulfurudes audaxviator, does it all alone. It has never touched sunlight and does not need it. The radioactive decay of uranium in the rock splits water apart, and the bacterium harvests the energy from that, pulling its carbon and nitrogen straight from the stone and the gas around it. It is about as close as life on this planet gets to running on a different power source than the rest of us. This was Promise 2. An ecosystem of 1, 2 miles down, feeding on radioactivity in the dark. Each of these survives one impossible thing. The last specimen survives all of them, and then survives something none of them faced. Specimen 7. The Tardigrade. 1/2 millimeter long, plump, almost cute under a microscope, and the toughest animal ever measured. Its trick is called cryptobiosis. When conditions turn deadly, it forces almost all the water out of its body, pulls in its legs, and folds into a dried barrel called a tune, swapping its water for a glass-like sugar that freezes its biology mid-step. In that state, it has survived being heated past boiling, chilled to nearly minus 270 degrees, a breath above absolute zero, pressed under more force than the deep ocean, and dosed with radiation thousands of times what would kill us. It has been revived after more than 30 years frozen, and in 2007 on a European space mission, dried tardigrades were carried into orbit and exposed directly to the open vacuum of space. Given a drop of water back on Earth, most simply woke up and walked away. This was Promise 3. To be honest, there is one limit. Full, unfiltered sunlight is the thing that kills them in numbers, and an active, hydrated tardigrade is as fragile as any tiny animal. It is not indestructible, it just refuses to die in almost every way we can invent. So, those neighbors. Where would I send the probe? Not Mars, at least not first. I would look at Enceladus, a small icy moon of Saturn, because under its frozen shell is a warm, salty ocean, and at the bottom of it there seem to be hydrothermal vents. Heat, water, salt, Chemical energy? No sunlight required. The exact address where, on Earth, this whole list began. And that is the thread tying all 7 together. Not one of these organisms is breaking the rules of life. They are showing that the rules were never what we assumed. Habitable was always our word, measured against our own narrow comfort. These things traded sunlight for chemistry and armor for repair, and quietly redrew the map of where life can exist. It is why the search for life beyond Earth stopped hunting for a second Earth and started hunting for exactly these conditions in the ice oceans of Europa and Enceladus, in the buried dark of Mars. The most unsettling possibility was never that we are alone. It is that the aliens we are looking for might look a great deal like the things already living under our feet. If that's your kind of weird, the next file is already on the shelf. I'll see you in the lab.